Welcome to the PharmaSource podcast. Today's interview is with Dr Tony Cox, CEO of UK Biocentre. Tony was awarded an OBE for the UK Biocentre's work during the pandemic, during which time it became the UK's first and largest lighthouse lab, putting all of its efforts into testing COVID samples, rapidly increasing staffing practically overnight. UK Biocentre is now the main processor for many of the UK government's genetics projects, including the Our Future Health project, with its ambitions to store the genetic samples of 5 million UK residents. All in, UK Biocentre can store 35 million individual samples. First, a short message from our sponsor.
The PharmaSource podcast is sponsored by Thermo Fisher Scientific. Thermo Fisher Scientific provides industry-leading pharma services for drug development, clinical trial logistics, commercial manufacturing and clinical research. They partner with customers in the pharmaceutical, biotech and life sciences industries as their trusted CDMO to deliver medicine to patients faster.
On with the interview. Tony, thank you so much for joining us today. Pleasure to have you on the podcast.
Well, thank you very much for inviting me. It's great to be here.
I'm interested to hear about your background and where it all started for you.
Sure. I'm a molecular biologist by training, and my original PhD was actually in plant systematics. I'm interested in the sort of evolutionary relationships between organisms, and I did my PhD at the Royal Botanic Gardens at Kew. Had a great time there. But during that, kind of got interested in informatics and programming, and so moved on from Kew and joined the Sanger Institute during the days of the Human Genome Project, and spent a good number of years there in various roles in informatics, but more latterly working on research and development of the large-scale genome sequencing and genotyping pipelines that were run at Sanger. And then latterly, about 4 years ago, I moved here to take over the helm at UK Biocentre, and it's been a wild and interesting ride ever since.
Absolutely, and we'll be getting into all of that shortly. But for the uninitiated, I wonder if you could explain what biobanking is as a concept, please, and why it's important.
A lot of research biology is predicated on samples. They're the sort of the ground truth for a lot of research. They're absolutely vital resources that underpin the sort of research endeavor. So the long-term maintenance of those samples is vital for the integrity of much research that goes on. So biobanking is really about how to collect, maintain, and safely store those collections of samples, so that not only are they there for reference in the future, but they can be used transactionally to support further research. It sounds like a straightforward thing, but anybody who's owned a -80 freezer in a lab knows that keeping hold of collections and actually looking after them to a high level of quality and maintaining them, making them accessible and make stuff findable is actually not straightforward. So we do it at very large scale. So we have storage, highly automated cold storage, -80 storage for 30 million samples. We run hundreds of liquid nitrogen tanks. So it's quite a big sort of infrastructure, maintaining all of that and making sure that all of those samples are both safely stored, but also appropriately stored and retrievable is quite a complex thing to do.
Yeah. For commercial pharmaceutical companies and biotechs, what's the best way for them to engage with biobanks?
I think getting in touch with a provider. One of the things that we try and do is get in touch or get involved with projects at an early stage. If you're running a study, you're running a clinical trial, thinking about the end game of that trial can be really, really important, because many of the resources that are collected during a trial need to be preserved potentially for years or maybe even decades. So we help manage and sort of advise on the collection strategies for those trials, but also the long-term storage. Something as simple and mundane as choosing the right tube that samples will end up in could have, cost implications and, in terms of hundreds of thousands of pounds of savings if things then end up in the right format, in the right way, so that they can be stored really efficiently. So, we try and, talk to our customers in advance, give them advice, try and understand what they're trying to do, what they want to achieve, and then help them to sort of build a process with the right sort of reagents and plasticware that gives them that sort of long-term efficiency.
So engaging as early as possible, would you say, within the clinical trial?
Ideally, yes. I mean, what you really don't want to do is find out at the end of your trial that it's going to be really expensive to store samples in whatever plasticware they're in, and then have to go through the sort of the time and the cost of perhaps reformatting them into other more efficient labware. So we although we can do that, it's much easier to sort of get involved earlier and provide that advice. So early engagement's really an ideal way to go about it.
Earlier, Tony, you mentioned the scale of UK Biocentre and the capacity that you have. If you cast your mind back to the year 2020, when UK Biocentre was a really significant part of the UK government's Lighthouse Labs, could you tell us about that, please? How was 2020 for you?
It was an interesting year for sure. So obviously we have, because of our origins, we had quite close ties with the NIHR and the DHSC, and we specialize in large scale sample processing projects. So we process tens of thousands of blood and other samples a day here. So we know how to do scale and do it well. So it was natural for them when they were looking for laboratories that were capable of setting up large-scale testing for COVID to come and talk to us. And I got a phone call from the department to say, could we help? And my view was that everybody had to kind of, step forward at that point and do what was necessary. So from about March onwards in 2020, we more or less converted the entire operation to focusing on supporting COVID testing. And in fact, we over the period of the next 2 years, we built a big sort of testing pipeline, totally focused on COVID, testing up to 100,000 samples a day at the peak requirement. We did well over 30 million tests during that time. So, it was a very intense time, but I'm very proud of, what we stepped up and did as a company and as an organization to sort of, support that whole testing effort. It was a very busy 2 years, but it was also very interesting. We learned as an organization an awful lot from that, how to do scale, gain organizational confidence to do things. I don't think anybody would come to me with a project now and you think, oh, I'm not.
After doing that,
I don't know whether we can do that. It's a good feeling to have that confidence as an organization, because I know the team here would always step up to a challenge.
With that, I mean, just logistically, how many people did you have to bring in at its peak? And then what happened afterwards when the pandemic started to recede?
Well, I think when we first got the call, we were an organization of about 45 to 50 people. So, not tiny, but in no way big. But over the course of the next 12 months and at the peak of testing, we went up to well over 1,000 employees. We were operating 4 shifts, 24 hours a day, 7 days a week, with a lot of staff sort of coming in and out of the building in sort of organized shift work. Lots of complexity with managing, contact between shift groups, managing bubbles. It was a huge operation. And then of course when testing sort of wound down, we went down from over 1,000 employees to something like 70 or 80 overnight. It was a very big sort of change. So we've been through some really enormous changes, and some sort of startling experiences. I know I lived out of a hotel room for the best part of 18 months during that. So
did you?
Because I just couldn't, had just have to be around to sort of to keep the wheels on the bus.
Yeah. And presumably any client projects had to be paused.
We did. We had to. So there was a sort of a controlled process whereby we worked with our customers to sort of essentially hibernate our projects, because many of our customers who were collecting samples, their own clinics were closed down as part of the lockdown. So there was a natural pause in those processes. Mm-hmm. But many of them began to start sort of waking up and coming back online after about 9 to 12 months. So we gradually sort of brought those back. By the time that the COVID operation stopped, virtually all of our projects were sort of coming back to life. So it was a sort of a complete switch of focus from one thing and then back to the original core business.
Yeah. Increasingly, there are concerns about how bad actors and nation states might be able to access DNA data. So the Biosecure Act, which is passing through Congress at the moment, is a good example of that, and how the US is trying to protect itself. What advantages would you say there are for harvesting DNA? What could it give to an adversary? And I guess as an industry, how can we mitigate against this kind of risk?
Yeah, I mean, having knowledge of a person's DNA is obviously not only a gross violation of the privacy, but it does open up significant vulnerabilities, and I can understand why there is increasing concern and nervousness about what is happening to that data, because very large amounts of it are being collected now, and it's not clear what the long-term sort of opportunities for bad actors will be to exploit that. So I think it's very important that we think very long and hard about how to protect that data. We as Biocentre, we don't collect any data about our samples that we manage, other than what's necessarily generated as a part of the processing. We don't hold any patient-specific information. Mm-hmm. But I think there is an increasing trend for both companies and research organizations to use trusted research environments to aggregate and hold their data, where that is both very secure in and of itself, but also has very strong safeguards for managing access to that data. There is no direct sort of visibility of the data in those environments. And I think those sorts of developments, I think, help to assure participants in these large studies that data will be managed responsibly and securely for what is essentially, many years to come, and indeed sort of the remainder of their natural lives and past that. Because it's not only the implications for the individual, but of course, because it's DNA, it's also your descendants, your children, your grandchildren, and all of that. When you begin to think through those implications, it's a very significant subject to make sure that we think about deeply and get right.
Do you think the UK might pass a similar act? I mean, what are the noises that you're hearing?
I think it's entirely possible. Yeah, I mean, I think a lot depends on public confidence in those organisations which are increasingly collecting important data. Obviously, the NHS has growing programs to include things like genome sequencing as part of individualized healthcare and diagnostics. It's vitally important that public confidence in those and other services remains high. So I can see that there will be pressure to demonstrate the long-term security of those data resources. There's a tension because, increasing they're hugely valuable for research, over and above just how they were generated for diagnostics potentially, and that a balance has to be reached where we can derive the benefit from that data for future research, and but absolutely without compromising security for the individual.
Yeah. UK Biocentre is involved with the Our Future Health project. So I'm interested to hear a bit more about that and what its goals are.
Sure. Yeah. So Our Future Health is a huge project. It's very exciting. It has huge aspirations to collect and engage 5 million participant volunteers in the UK to collect both health questionnaires, biological samples, and links to health data to form a very large prospective healthcare study looking at the factors, both genetic, environmental, and other, that lead to ill health in later life. I think everybody is aware that the NHS is under severe strain, and there's a recognition that we have to shift from treating people when they become ill to doing research in a way that will allow people to inform people about what their risks are, so that they have the information to more effectively manage their own health, to allow people to live longer, sort of healthier lives, and thereby not only improve their quality of life, but also reduce the strain on the NHS in the future. It's the only way that we are going to create, a sustainable health system that is affordable. So, I'm hugely excited about Our Future Health because I think it has, it's got huge ambition. 5 million people in the UK, and 10% of the population contributing to this enormous project. We're involved because we are processing the samples for that project. It's gaining huge traction, and I think it has huge potential to sort of really turn the dial on helping us to understand what our health risks are and how to effectively manage them.
Tony, if I could ask you a bit more of a slightly more personal question. So much of your education, your career has been involved with genetics. What is it that motivates you? And if you pardon the pun, what would you like to pass on to the next generation?
I've always been fascinated by DNA and the concept of information moving between generations. It blows my mind that something as simple but as complex could have arisen. It's remarkable. I've always found that interesting, and I think we have a hugely sort of supportive and vibrant life science sort of sector in the UK. It's a fantastic place to be doing genetics. So I think it's going to be heavily influential in many areas of our lives around healthcare and other sectors. And I think it's a great area to be involved in. It's fascinating. It's fast moving. It's if you're technically minded, it's got lots to offer. If you're interested in society and ethics or medicine. It really is a fantastic area to be involved in. So yeah, I've always been fascinated. There are so many interesting areas in it that can essentially suit everyone's interests. So yeah, I'm a big advocate for life sciences and for young people who are looking for careers, who might not necessarily think of something that's highly technical. It doesn't necessarily matter. There are lots of interesting areas to be involved in, and it's such a it's a big national strength for the United Kingdom, and I think there's lots of opportunity for us to not only maintain that sort of preeminent position in the world, but to also improve it.
Are there any particular cell and gene therapies or particular modalities or areas which you've got your eye on at the moment?
I was at the Festival of Genomics earlier on this year, and there was some fascinating talks there about rapid development of oligonucleotide therapies in rare disease. Rare disease has such a cumulatively a very high burden on the health service, but individually, very small number of cases. So there's a sort of real paradox in how you approach treating these rare diseases, which really can be incredibly debilitating for those who suffer them. So, there were some really interesting and innovative ways in which rapid development of highly tailored therapies were going into both, very focused trials, but also manufacturing. And I just was struck and excited by the fact that this really tight, focused turnaround could be, an opportunity of the future, because we're all, almost programmed to think that clinical trials are going to last decades, and it's going to be many, many, many years before something that's identified as a potential therapeutic will end up in a pharmacy that we can actually take advantage of. But, some of these new mechanisms, especially based around using genetics to focus the benefits of individual therapies, hugely exciting. Yep. I think that's definitely one that I'll be watching.
Tony, fascinating speaking to you today. Thank you so much for your time.
It's been delightful. Thanks very much.
Thank you to Dr. Tony Cox for that insightful interview. For more insights into the biopharma supplier ecosystem, head to pharmasource.global and sign up for our weekly newsletter. And thanks again to our sponsor, Thermo Fisher Scientific. Thank you for listening.